Welcome to the prerequisite review exercises. This is review packet B. The first task you're asked to do is graph a line by hand, y equals negative 3x plus 2. You're asked to make a specific graph, and I'll talk about what that means for me in my class right now. A couple ways to get at this. I tend to think of this as an equation of a line that's already written in slope-intercept form, and so this point hanging off the end here, this corresponds to the point 0, 2 on the graph, or the y-intercept. So that gives me a starting point on my graph, 0, 2. This negative 3 that is the coefficient on x, that is the slope of your line. And we use m for its symbol. And you can write it as negative 3 divided by 1, or negative 3 over 1. And this, remember, is rise versus run. And so this would indicate that we would want to go negative 3 in the vertical direction from our starting point, or go down 3, 1, 2, 3, and go right 1 unit to get to another point on the line. You can go down 3 again, 1, 2, 3, and right 1 unit. You could also go up 3, 1, 2, 3, and left 1. You need one negative direction and one positive direction. And then connect these points with a straight line. Mine are not always very straight on the first try. If you want to use a straight edge, feel free to do so. Okay. And this would be a detailed, specific graph. We have a few points bubbled in. We have arrows on the ends of our line. We have the line filled in. The scaling was already given in the graph, but if you had to start from scratch, you'd want to include some scaling. After this, we are asked to list some points that are on the line and then verify algebraically that they are definitely on the line, just in case we made a mistake. So if I look back up here, I can see these 3 points in the screen still. The first one that I plotted was 0, 2. X is 0, y is 2. And I'm going to make them look like ordered pairs. The next one that I plotted was 1, negative 1. And then the next one was 2, negative 4. To verify that these are definitely on my line, I take my xy pair and I plug it in to the original equation. The original equation, we can't see it anymore, but it was y equals negative 3x plus 2. Y's replacement will be 2. 2 equals negative 3 times 0 plus another 2. And we're checking to see if we get a true statement. When you work out the arithmetic on the right-hand side, we do get a true statement, and that means that the line does contain the point 0, 2. That one is correct. Same kind of plan for any other 2 points that you choose that were on your line. We will plug them in individually. In this one that I have written down, 1, negative 1, y's replacement is negative 1. So negative 1 equals negative 3 times 1 plus 2. Then we check the arithmetic. On the right-hand side, we should get negative 1, and I think we do. Negative 3 plus 2 is negative 1. This one is also true. The last one, negative 4 is the replacement for y, equals 3 times 2. I lost my negative. Equals negative 3 times 2 plus 2. So negative 6 plus 2 is negative 4, and this one also works. There was a moment there when I was worried. So this first problem is about graphing lines by hand. You could make a t-table to start with, but I do think we should be at least heading toward using the slope-intercept form for making graphs. The next task on this page, or the next thing to work on, number 2, rewrite the equation 9x minus 3y equals 15 in slope-intercept form, showing the process. So pretend like someone needs to read all of your steps tomorrow when they look at your paper. After you're done with that, state the slope and y-intercept of the graph, and the y-intercept should be listed as an ordered pair. I usually rewrite the equation 9x minus 3y equals 15. We would like to isolate the y. And so the first place to try to do some work is with the 9x. Subtract 9x from both sides. You'll get negative 3y is equal to negative 9x plus 15. To undo the coefficient of negative 3 on the y, we need to divide everything by negative 3. When you do that to every term, you'll end up, after simplification, with y equals 3x minus 5. So this means that our slope is 3. Our b value, or our y-intercept, is negative 5. You can just record those over here, being very careful. Slope is 3. Y-intercept is an ordered pair. Every y-intercept on the planet has an x value of 0, and then we fill in the negative 5 in this case. So the first page is done.